Good morning friends. Next our experiment is reactive power for star load. So this is the actually reactive power for star load connecting diagram. Okay, you remember this one, this diagram always. Okay, so already I have given connections. So as per circuit diagram, so this one for reactive power for star load. So whatever the delta load connection we given, the same connections, but just whatever the loads here we are taking R load of delta load we are connecting to star load, and Y load of delta load connection is connected for Y load of star connection, and delta load of B connection directly connected to B phase. Okay, so everything is same, whatever the connection we given in a reactive power delta loads, so the same connection. So once again we are discussing those connections one by one, you remember. So here, so R phase is directly connected to voltmeter first terminal. So R phase is directly connected to voltmeter first terminal, and then from the same terminal, first terminal to ammeter, from same terminal voltmeter to ammeter, and ammeter to ammeter second terminal to wattmeter M, ammeter second terminal to wattmeter 1, and next same wattmeter L to varmeter M, same wattmeter 1 to L is connected to varmeter M, varmeter M terminal, and then L is directly connected to resistive load. It's mean varmeter L is directly connected to R load, and next here in this wattmeter MC we are not short circuited here because this one is a varmeter, that's why C is directly connected to Y of star load. C, common terminal C is connected to Y load, and V of varmeter is directly connected to B phase. This one is a V of varmeter V is directly connected to B phase load of star connection. Okay, and then remaining here already we know that simply the connection is, so first wattmeter V is connected to Y and Y is connected to second wattmeter V. This connection is same. So in varmeter you remember here totally we have 4 terminals. So L, M and common terminal and V. So here in wattmeter we are taking MC shorted, but here we are not doing that MC shorted. Here also wattmeter MC shorted, but in this wattmeter we are not doing a MC shorted because this one we are taking for var measurement. Okay, what is the reason here wattmeter and varmeter? In the sense MC not shorted, that one only the difference between wattmeter and varmeter. Here external panel, whatever the panel is there, so in that panel varmeter already damaged, so that's why I have taken one external wattmeter. So that wattmeter I have converted into varmeter. Okay, so here you remember 4 terminals are there, L, M and common terminal and V. So M is directly connected to wattmeter 1 L wattmeter. So in varmeter, M is directly connected to wattmeter L, and remaining 3 terminals are there now. After that M terminal, we have L common terminal and V. So this V and L and common terminal, these 3 terminals we are connecting for 3 points of the load. So R, Y and B. Okay. So in that C is connected to Y load and V is connected to B load and L is connected to R load. That one only 3 terminals here. So L is connected to R load and C is connected to Y load and V is connected to B load of varmeter. Okay. So this is the connection. Then we are going to turn on the MCB and vary the variac. Up to 400 volts. So here I am taking 400 volts voltmeter reading. For a 400 volts zero load condition, there is no any current, there is no any power into wattmeters. In varmeter also there is no any value, okay, 0. Then when I am going to apply a star load, you remember for 400 volts we got 1.15 amperes. Here in wattmeter approximately we got 300 watts, and a second wattmeter approximately we got 600 watts. So in varmeter we got 63 value. So that 63 value we can take it multiplication factor 4. Okay. So for 400 volts in load condition we got 1.15 and 300 watts and 600 watts and 63 value. Okay. You remember in previous case delta connection, so whatever the delta load we are taken, so in that delta load we got 2.38 amperes current, but here in star load we got current value just 1.15. You remember what is the difference between that one and this one? In the sense, star connection is just like a open loop system. So because of that, in open loop system voltage is very high, current is little bit less. So delta connection is just like a closed path. So because of that we can get it very high currents. So in delta load, okay, in star load we got only less current value. So that is the major difference between star load current and delta load current also. You remember star is just a open loop system. In open loop system voltage is high and current is less, and closed loop system current is high and voltage is very less. That is the reason in delta connection we got current value is high compared to star load. So because of that, whenever the current increases, then automatically power also increases and as well as var reading also increases. So here calculation also we can observe here calculation, the same formula pi is equal to tan inverse root 3 W1 minus W2 by W1 plus W2. Okay. So we can substitute all the values 300 and 600 here. So W1 is 300 and W2 is 600. So then substituted, then we got it minus 29.98. So that value is a pi value. That pi value we can substitute in cos pi, in the sense we can get it here 0.86 lagging. Then again experiment is practically proved, because whenever in inductive load, so you remember here in delta connection, sorry, star connection. So here this one is a resistance and this one is a inductance. Okay. So, there is no any connection in between these two values here. So, this one is a resistance and this one is a inductor, there is no any connection, that is why I have taken one connection in between resistance and inductance. So, for each load condition, okay, and this one is a neutral point. So, that is the difference between a low delta load and a star load. So, in inductive case, whatever the inductive case we are taking, in inductive case current is lags with the voltage, because of that in inductive star load also we got here lagging power factor, because current is lagging, in the sense automatically power also, so power factor also lagging. So, that is why in inductive load we got only lagging power factor, then only the experiment we done, that one is right, or otherwise whatever the experiment we done, that one is a wrong. So, then again 3 phase reactive power we can take here, formula is root 3 into Vi into Ii into sin pi. So, from that we can take it root 3 into 400 volts we have taken. So, input. So, we got here current is 1.15 into sin 29.98 plus you have to take it. So, here we got minus. So, minus also we can substitute, then we can get it entire value is minus 405. But so this one is not a correct calculation part, but you have to take it this sin value from calculation of cos value. So, cos pi we got 0.86, from that pi we can calculate, pi is equal to cos inverse of 0.86, in the sense we can get it pi value equal to 30.68. From that sin pi equal to sin into 30.68 we can take it, in the sense we can get it 0.510. Okay. This is the calculation part of the reactive power. So, 3 phase reactive power for star load.